Okay, welcome back. We're going to do another video today on 9.1, 9.2. I know I'd mentioned in the past a couple of times about possibly doing YouTube Live, but every camera that I had that I could possibly have done that with ends up being pretty terrible quality. So I have a camcorder here. We're going to try this. Hopefully it's better quality. I tested it out. It looks like it'll be much better. So we're going with that. I think this is what we're going to do. I'll just keep posting these typically around noon-ish on the day of the discussion that we would normally have about these sections. So I had some questions about 9.1. I'm going to do a 9.1 video and then I'll do a 9.2 video. So here's 9.1. So the first one is number 10. And again, I think you can see that better. It's a better quality video I'm taking, so hopefully this will work out a lot better than what we've had. So the question on number 10 was to find for a particular vector u, which was 6i minus j. And when you're writing these, a lot of times, especially engineers will write an I hat. So they'll just put a little hat marking on top of it, and then minus a j, and then again a hat. But this is our vector, and to find the magnitude of this vector, and if we're writing a vector u, typically we'll just put an arrow with just the top bend. But the magnitude is just the Pythagorean. It's the x value squared plus the y value, which is -1, squared. And so this is the square root of 36 plus 1, and that's the square root of 37. And that's my magnitude. So, yeah, easy enough, I suppose. The next one was number 14. Number 14 is that we have a vector, some vector, whose magnitude is 8 and has an angle, theta, of 210 degrees. And the question was to find that vector. Alright, so this vector then, v, is 8 multiplied by the cosine of 210, comma, the sine of 210. It can be rewritten as its magnitude multiplied by the cosine and sine of its angles. If you distribute that through, this becomes simply 8 times the cosine of 210, comma, 8 times the sine of 210. With the cosine of 210, right, just know where 210 is. It's past 180. It's past 180 by 30 degrees, right? So it's this angle down here with a little 30 over here, okay? Which tells me that the cosine is negative. And it's the root 3 over 2. And then the sine is also negative, and it's just 1/2. So if I simplify this, the 8 acts like it's in the numerator, divides by 2 gives me a 4, times negative root 3 gives me -4 root 3. And the 8 divided by 2 is 4, and it's negative, so -4. And that's my angle, or sorry, that's my vector v. That was, sorry, that was number 14. I didn't write it, but that's 14. Next one we had was number 17. 17 gives us a vector. That vector is 3, -5. And we're asked to find the angle of that vector. So the angle is simply an arctan, right? This vector, if you draw it out, has an x component of 3, and a y component of -5. So it's just down there. So I know I should be able to get some angle that puts me down into quadrant 4. And I can do that simply by using the arctan of the y value, -5 divided by 3. Right? That's not a nice known angle, so I have to throw that into a calculator or Mathway or Wolfram Alpha. And I did that and I got something around -59 degrees. Which makes sense. I'm down there in quadrant 4, but the question asks you to put your angle between 0 and 360. So I just have to bring it into the first positive circle, and so all I have to do then is add 360 to this. It gives me, instead of going negative, it puts me going the other way, and that gives me an angle of 301. So the angle between 0 and 360 that works is 301. And that's going to be a theme, I think, for the next couple of problems. Whenever it says find your angle and make sure it's between 0 and 360, we want to make sure that we can drag it into that correct quadrant. Since we're using arctan also, arctan will spit out answers in either quadrant 1 or 4. So if our vector is obviously in quadrant 2 or 3, we'd have to add. We'd have to add 180 to bring it back into the right quadrant. So let's take a look at, let's do 18. 18 is the same question with the vector √3, comma -1. And so again I've got this theta is the tan inverse of my y value, which is -1, divided by my x value, which is the square root of 3. If I think about where this is, that is again in quadrant 4 because I have a positive x value, or a positive x component here of √3, and a negative y component. So that's my vector. I should end up in quadrant 4. But again, to add, to get into quadrant 4 but to be between 0 and 360, I'm going to have to add to get myself into the correct area. So again, I can, this one I should know. I don't have to plug this into a calculator. I should know this guy. Tan of -1 over √3 is going to be negative 30 degrees. But again, that's the same thing as a positive 330 degrees. And so that's the answer we're looking for in the homework. Okay. That was 18, right? Let's take a look at 19. Gives us a vector v is -1 I hat and -1/2 j hat. And we're asked to find the angle again. So theta is again the tan inverse of the y value, which is -1/2, divided by the x component, which is -1. So that is to say, I want the tan inverse of, well, -1/2 divided by -1 is still just +1/2, right? But my vector is clearly in quadrant 3 because I have a negative x component, -1, a negative y component, -1/2. It's down here somewhere, right? I'm in quadrant 3, but if I take the tan inverse, I'm going to end up in quadrant 1 or 2. So to adjust for this, I have to add 180 degrees to that, right? So if I'm going to be put into the wrong quadrant, add 180 to get into the right quadrant, right? 1/2, that's not a nice value you can take the arctan of. So I threw that into a calculator and I got something around 27 degrees. Which again would be in quadrant 1, right? Up in this direction. So I add that 180. And I get, what, 207? And that's the answer we're looking for. So somebody had mentioned 20. I think after doing 18 and 19 you could do 20, so I'll leave that for you guys to do. Let's take a look at 21 though. '21 was the, I think it's the boat one. I have a boat. It's going, I think it was 8 miles an hour. Across the river, and the river is going down at 4 miles per hour. So if I'm representing these with vectors, this 4 should be smaller. And maybe even blue, because I think you can start picking out colors on these videos a little bit better now. But I've got that. I've got a boat traveling across the river at 8 miles per hour, and the river itself is moving at 4 miles per hour down. So I can think of the boat as moving in the x direction, and so the velocity of my boat, I can say, is 8 in the x direction, 8 because it's moving to the right, but it's not moving up or down relative to the water, so I would say that it has a vector of 8, 0. Whereas the velocity of the water is completely in the y component. There is no x component to the flow of the water, but it's going down, so I'm going to call that negative. It's going down 4. Okay. And so when this boat gets into that water, its true vector relative to the land is going to be the sum of those things. Right? So it'll be in that direction. And that's just adding these. So the true velocity relative to land, maybe I'll call that v sub l, is 8 plus 0 is 8 in the x component. 0 plus -4 is -4 in the y component. And so that's the velocity. And that's actually the second thing that the question asks you for, is the velocity of the boat relative to the land. Right? The first thing they ask you for is what the magnitude of the boat is relative to land, and I need this to do that, so it's simply the magnitude of the velocity relative to land, which is the square root of 8 squared plus -4 squared, or the square root of 64 plus 16, which is the square root of 80. It asks you to actually evaluate that and then round it to the nearest decimal. If I remember right, that's just barely under 9, that's 8.9. So I should get something like 8.9 for the magnitude of that boat, and I think that's right. So. Alright, this was 9.1. I'll post this as well as questions for 9.2. I'll do 9.2 in a different video so that you can maybe not have to watch 40-minute long videos just to find one question in 9.2. But there we go. There's a email I sent out about the test. If you got that, I'm going to go through the test and try to see if there's any manipulation I need to do with those. And then chapter 11, I just posted all of the homework for chapter 11, so you can get into that as well, because we're supposed to start 11.1 Wednesday, I guess we're supposed to do it. So anyway, here we go. We'll see you next video.